This technological wonder generates its own electricity from the light of the sun, making Picard and Borschberg the worthy heirs of the pioneers who tamed and domesticated electricity.
In less than 2 centuries, electricity has become indispensable to our lives and impossible to live without. It has changed our world for the better, but also for the worse. Our incessantly growing needs threaten the environment and are changing the climate of our planet. Yet, the planet itself offers the means of producing electricity in a cleaner way with renewable energies. Every minute, everywhere in the world, renewable energy sources are producing phenomenal power. The sun alone sends the Earth more energy in an hour than humanity consumes in a year. By flying day and night without fuel, Picard and Borschberg carried a message of hope around the world. It all started with a dream.
Bertrand Picard, the father of solar impulse, grew up surrounded by pioneers and explorers.
As far as I can remember, I've always been fascinated by exploration and scientific adventures.
His grandfather, Auguste, invented the pressurized cabin and was the first man to fly into the stratosphere and see the curvature of the Earth. His father, Jacques, used a pressurized cabin in a submersible to descend to the deepest part of the world's ocean, where he found life at the bottom of the sea.
The adventure today is not about returning to the moon. It's about achieving other, just as incredible feats, like freeing ourselves from our dependency on fossil fuels, or resolving environmental problems, but in a cost-effective way. Otherwise, no one will ever support environmental protection. But what is absolutely essential is allowing ourselves to dream.
The pioneers of electricity held onto their dreams and changed the world. Before them, without electricity, life was very different. The ancient Greeks believed that lightning was made for the god Zeus by the 3 Cyclops. Greek philosopher, mathematician, and astronomer Thales knew that amber had strange properties. The Greeks called it electron. When rubbed with an animal skin, electron attracts dust and produces tiny electric shocks. 23 centuries of different civilizations came and went, with hundreds of inventions that improved human life. Yet, electricity was not part of this progress. By 1749, electricity was still thought of as a strange fluid and a fashionable curiosity that was shockingly amusing. The true nature of lightning remained unknown until Benjamin Franklin. This science-loving American theorized capturing lightning would prove its electric nature. No one took him seriously until his experiments were tested and he was proved right. His lightning rod became a huge hit around the world. Ultimately, Benjamin Franklin demonstrated that electricity is a natural phenomenon.
Bertrand is an incurable adventurer. In 1999, he and Brian Jones completed the first non-stop trip around the world in a hot air balloon. When they landed at the end of this 20-day adventure, their fuel tanks were almost empty.
When I saw what was left in the fuel tanks, I promised myself that I would make another flight around the world, but this time without a single drop of fuel. And symbolically, Solar Impulse was born that day.
Bertrand would pursue this dream for the next 16 years. To fly around the world without fuel. But how? A blimp is too sensitive to wind load, so is a glider, which can't even take off on its own. You need an airplane with an electric motor powered by a battery that can be recharged in flight. Covered with photovoltaic cells, the plane can generate its own electricity from sunlight.
A photovoltaic cell converts sunlight into electricity. It is made of a thin slice of semiconductor material, usually silicon. Chemically treated, the slice shows a negative and a positive layer, with an electric field in between. Exposure to light forces silicon's electrons into action. When the two layers are linked by a circuit, electrons move from one layer to the other. This is electric current. As long as they're exposed to light, the cells produce electricity.
Previous solar planes have shown the limitations of solar power as they had to land when there were clouds or at sunset. So how can a solar-powered plane keep flying at night? In 2002, Bertrand found the answers at EPFL in Switzerland, one of Europe's top science and engineering schools. Andre Borschberg, entrepreneur, MIT graduate, and ex-fighter pilot, took the lead in conceiving and designing an innovative solar-powered plane.
When there is not enough light, a solar plane has to switch to its batteries to continue flying.
The first battery was invented by Italian scientist Alessandro Volta. His compatriot, Luigi Galvani, believed electricity was of animal origin after hanging dead frogs on a copper hook from an iron balustrade and observing the frog's legs contract. But Volta proved that electricity came from the contact between different metals. Making a pile of silver and zinc discs, he obtained a direct current for the first time. In 1800, the world still had no knowledge of electricity. But Volta's discovery marked the beginning of a new era.
The Solar Impulse feasibility study took 1 year of calculation, simulation, and design.
1 year to invent the first perpetual flight airplane and bring it to life on paper. In theory, it could fly day and night with engines powered by both sunlight and batteries. 4 batteries for 4 especially efficient electric motors.
The principle behind the electric motor was discovered by Michael Faraday. This self-taught English chemist and physicist combined magnetism and electricity. He succeeded in transforming electric energy and perpetual mechanical movement, paving the way for the electric motor.
Solar Impulse's engines are almost 97% efficient, while the efficiency of a gasoline-powered car engine is only 30%. This means we waste 70% of the fuel we put into our cars. Bolstered by their feasibility study, Bertrand and André approached the major aircraft manufacturers. But the response was always the same: impossible. André took over the responsibility of building the airplane with the team he set up.
It took 10 years for Michael Faraday to reverse the principle of the motor and invent the first electric generator. Soon, these experiments would leave the laboratory to rapidly conquer the world. The first practical application of electricity that really changed people's lives was the telegraph. Information could be sent in seconds instead of weeks.
And I pronounce man and wife.
Samuel Morse, a New York artist, was responsible for this leap in progress when he found a way to transmit electrical signals over a wire laid between stations. In 1844, the first telegraph was transmitted in Morse code between Washington and Baltimore. Very soon, telegraph lines crisscrossed the United States and Europe. By 1858, the first undersea cable was connected from one side of the Atlantic to the other.
Crossing the oceans in their solar-powered plane was the biggest obstacle Picard and Borschberg had to overcome. Because the aircraft manufacturers refused the project, Bertrand and André oversaw the construction of the plane structure in a boatyard. Only boat builders had the skills to make the airplane light enough for the best energy efficiency.
Its structures and cladding will therefore be made of carbon, a skin 4 times thinner than paper and applied with an iron.
The first electric iron was invented in New York City in 1882. At the time, its star innovator was Thomas Edison. He had a number of inventions to his name, but it was his electric light bulb that brought him international fame.
Totally covered with photovoltaic cells, Solar Impulse was the result of the perfect ratio between weight, size, and electric motor power.
Each square meter of solar cells provides enough energy to fly 8 kilograms. To carry the heavy batteries necessary to fly through the night, the wings had to be gigantic.
Late in 2009, Solar Impulse embarked on its maiden flight with test pilot Marcus Scherdell in an unfinished cockpit. Solar Impulse had just completed its first flea jump, but the plane was dangerously unstable.
Dangerously unstable. This was precisely the problem of the direct current supplied by Thomas Edison. His first coal-fueled power plant, located in downtown Manhattan, delivered direct current electricity, but only over a very short distance. His solution was to build a plant every 2 miles. Nikola Tesla also dreamt of supplying the world with electricity, but by using an alternating current, which is easier to distribute over long distances. Tesla was hired to build an entire alternating current power grid by George Westinghouse.
For several months, numerous tests were carried out on Solar Impulse to gauge structural strength, aerodynamics, and vibrations.
Speaking of vibes, those between Tesla and Edison were not very good. There were such high commercial stakes in supplying cities with electricity that they sparked the current war. Edison orchestrated a campaign that tried to show how dangerous high-voltage alternating current was. Tesla closed the argument with a demonstration. He sat inside a Faraday cage that shielded him from a strong alternating current that lit the light bulb he was holding. As a result, Westinghouse was awarded the contract for installing the United States' entire electrical infrastructure. And to this day, almost all the electricity across the globe uses Nikola Tesla's technology. Power plants were built all over the world. Today, there are still only 2 ways to produce electricity: with photovoltaic cells or by driving a turbine that generates a current, like Faraday's generator. Turbines can be powered by renewable resources provided by nature, like wind. Waves and tides. Or waterfalls. And dams. Or driven by heating water to obtain pressurized steam. Using heat from the earth in geothermal power plants. Or from the sun and concentrated solar power plants. Non-renewable energy also powers turbines, using the heat from the fission of uranium atoms, or the burning of coal, gas, and oil in fossil fuel-fired thermal power plants.
Summer heralded the ultimate test for Solar Impulse, the first day and night flight for a solar airplane. Andre would have to rise to nearly 30,000 feet before sunset. The higher the altitude during the day, the longer the plane can glide at night. With its batteries fully charged before sunset, Solar Impulse would idle its motors and glide for about 4 hours, the time it takes to descend to 5,000 feet in altitude. At this height, the engines would switch back to cruise power, using the energy stored in the batteries until dawn.
Then, a new cycle would begin, with the sunlight recharging the batteries and powering the engines at the same time.
After 26 hours of uninterrupted flight and without having consumed a single drop of fuel, the dream of perpetual flight had come true. Now, Bertrand and Andre truly believed that Solar Impulse could take them around the world.
Imagine a flight around the world powered entirely by the light of the sun.
Solar Impulse's departure for its round-the-world flight was approaching, with an improved version of the aircraft being assembled in Abu Dhabi.
The wings were now watertight. The engines were a little more powerful, and battery efficiency had been optimized. Slightly bigger, but not yet pressurized. The pilot could put the seat back, and there was a lavatory as well.
With the wingspan of two Airbus A320s, but 60 times lighter, Solar Impulse weighed as much as a car, but had the power of a motorcycle. A truly exceptional aircraft. Very large, yet very light, this makes it extremely sensitive to turbulence and difficult to fly. The two pilots simulated countless flight hours to better understand the plane's flight characteristics.
Originally, I'm an explorer, not a pilot, so learning to fly Solar Impulse was terribly difficult. It took me 2 years of sweat, training, and tears to get there.
When turning, a passenger plane can tilt at a 30-degree angle. For Solar Impulse, anything above 10 degrees, the plane would go out of control, and the pilot would have to parachute out.
There are basically two situations where you would have to jump off the plane. When there is not enough energy to get through the night, and then you have 1 or 2 hours to prepare to jump. But it would be heartbreaking because it means abandoning the plane that is still flying very well. And there is the absolute emergency, where the engine or the battery is on fire, or a wing is melting because of the heat, and you have to jump to save your life. Then there is no time to say goodbye to the plane.
Solar Impulse is very sensitive to wind. In flight, a 30-mile-per-hour headwind is enough to slow it down and almost push it backwards. It doesn't take much wind to make landing dangerous. As for the sun, if the temperature is too high, all the epoxy in the plane can soften like chewing gum.
Solar power is on the way to becoming one of our main sources of energy. In 45 minutes, our planet receives energy from the sun equivalent to our annual consumption. The potential of solar power to produce electricity is therefore enormous, 4 times that of all other sources of energy combined.
All the parameters of the flight were transmitted by satellite link to the Mission Control Center in Monaco, just like a space mission. The plane and its pilot would be monitored day and night by 25 people, meteorologists, air controllers, flight engineers, and doctors. Prince Albert of Monaco gave the signal for takeoff on the first leg of the trip, from Abu Dhabi to the Sultanate of Oman. The first flights went on without a hitch.
In Earth's atmosphere, water vapor from clouds and carbon dioxide are the main greenhouse gases. They naturally maintain heat on the Earth's surface. Without the greenhouse effect, the climate would be freezing. Greenhouse gases are equivalent to the glass walls of a farm's greenhouse. The sun heats the ground, which reflects this heat as infrared rays, invisible to the naked eye. But the glass of the greenhouse blocks some of these reflected rays, trapping heat inside. While a balanced greenhouse effect is beneficial to life on Earth, this natural balance is fragile.
With room for only one pilot, Bertrand and André flew alternating legs of the flight. Each used his own relaxation technique, self-hypnosis for Bertrand and yoga for André. For the first time ever, a solar plane flew over China. Bertrand arrived in Chongqing, a megalopolis of 35 million people. Here, the message carried by Solar Impulse took on its full meaning.
If all the efficient technologies used on Solar Impulse were implemented today everywhere in the world, we could already cut mankind's energy consumption in half, and by the same token, CO2 emissions.
Now China is using its technological know-how to reduce its huge carbon footprint. At present, most of the world's electricity is produced by thermal power plants. These factories burn coal, oil, or gas, emitting tons of CO2 into the atmosphere. Since the Industrial Revolution, human activities have drastically increased the amount of CO2 naturally present in the atmosphere. The more CO2 there is, the greater the greenhouse effect and the higher the temperature of the Earth's surface. What makes it so hot inside a car in the summer is an extreme greenhouse effect.
On the Pacific coast, the weather had deteriorated, resulting in weeks of delay for the most dangerous leg of the journey. To fly non-stop between China and Hawaii required 6 days in a row of favorable weather over the Pacific. Finally, on May 30th, taking advantage of the first possible window of good weather, André took off for Hawaii. But the weather over the Pacific had deteriorated again, and Solar Impulse was grounded in Japan for another 21 days.
While weather is local for hours or days, climate is defined by average patterns across the entire planet over long periods of time. Climate has always changed naturally, but gradually, over thousands of years. A change of 5 degrees Celsius in 10,000 years is the difference between the climate of the Ice Age and that of today. This was enough to raise the level of the ocean by about 400 feet. At the current rate, we could see a 5 degrees Celsius increase before the end of the century.
At last, André got the green light to begin his non-stop flight of 5 days and nights over the Pacific Ocean to Hawaii. Bertrand was at the Mission Control Center for takeoff. This trans-Pacific flight was the moment of truth for the entire Solar Impulse team. Andre was relieved to finally be taking off on the flight of his life. However, his wife Yasmin was anxious, aware of the risk Andre was taking.
We all support you, Audrey, from all our heart. We wish you all the best and absolutely great flight. And although I try to make it sober, I'm really moved. You cannot imagine.
All day, Andre prepared himself and the plane for their first night over the ocean with just one objective: to stay in the air until morning.
The key to perpetual flight is energy efficiency. That optimum combination of ultralight materials, optimal thermal insulation, LED lighting, high motor and battery performance, and computerized energy management. All of the technology developed for Solar Impulse can be used in our everyday lives.
We absolutely need to replace all the outdated and polluting systems with clean, efficient technologies that are more profitable, that create jobs and economic growth. Because today, the goal is not to be ecological, but simply logical.
The pioneers of electricity would no doubt have loved this idea. But it took Bertrand and Andre to harness electricity to fly around the world.
Flying 5,500 miles over the Pacific, Andre was about to complete the longest solo non-stop airplane flight in history.
So now preparation for landing. It's incredible. I can't believe that is happening. And I knew I could make it. It was not a gamble. It's unbelievable. And that's true. I would like to stop the time. I mean, I'm almost emotional about it.
Morning had barely broken over Hawaii, but everyone was waiting for the plane and its heroic pilot.
As it landed in the Hawaiian dawn, Solar Impulse became the indisputable demonstration of the efficiency of clean technologies and a wonderful message of hope for humanity.
By completing the first round-the-world flight without fuel, the Solar Impulse team made history.
What was absolutely magical was to fly continuously for several days and nights, looking at the sun, looking at my 4 electric motors and huge propellers turning with no noise, no pollution, no fuel. And then I was saying to myself, I'm in the future, I'm in science fiction. But in fact, not at all. I'm in the present, in what today's technologies already allow, and it's the rest of the world that is in the past.
As our energy needs increase, adventures like that of Solar Impulse inspire us to look to the future with hope, because real solutions already exist, and they work. Even though we don't all have access to the same renewable resources, the power of nature offers enormous potential. And by using smart energy grid technology, each community and country can find its own solutions.
Today's energy challenges present industrial and technological opportunities that are profitable and will improve our lives and boost local and global economic development. So because at the same time we're protecting the environment, it makes me very optimistic.
Inspired by the examples of pioneers like Benjamin Franklin, Nikola Tesla, Bertrand Piccard, and Andrei Borschberg, today's generation of adventurers will work to improve our lives by ensuring the future runs on planet Earth.